Hello everyone, once again. Welcome to today's presentation. It's an introduction into Sungrow's highly scalable C&I ESS turnkey solution, namely the ST159KWH -50 HV. It's easier for me to sort of talk about the benefit before introducing the title. But to give you, from my point of view, my name is Jimmy Richards. I'm Key Account Manager with Sungrow UK, and I will be moderating today's webinar. In terms of a brief sort of background, it's a particularly exciting solution and one that I'm interested in personally, given it's a space that we can see real opportunity, particularly given where we are in the pandemic. There's a lot of indication that the uplift will be apparent in the commercial sectors as people look to sort of safeguard their, not only safeguard their energy costs, but also gain a better degree of management over their energy. And this solution certainly fits that need, in our opinion. The webinar is live. A recorded version will be available after the presentation and posted on our website. In addition, we'd love to hear from you guys as well. So please use the chat box, as some of you have been doing, to confirm the comms, to ask all your questions. We'll try and answer them as we go along. Otherwise, they'll form the basis of a brief 10 to 15 minute Q&A as required at the end of the presentation. So for any late attendees, if you're joining us, welcome. You just timed it pretty well, because now I'd like to introduce my colleague, Andrea Pellini. He's a project engineer with our ESS team, and I'm honoured to present him to you today for what should be a very informative webinar presentation. Welcome, Andrea. And without further ado, I'll hand over to you now.
Okay, great. Thank you, Jimmy, for the introduction, and thank you, everybody, for joining this webinar. I think we can start with the presentation now. So, yeah, thank you for joining this webinar. And today we are presenting our new C&I ESS all-in-one solution for the European market. It is named ST159KWH -50 HV, and it is a 3-hour battery energy storage system with a rated power of 50 kilowatts. The market for C&I energy storage has been evolving in Europe for the last few years, and actually right now, thanks to the European Green Deal at the moment going through the legislation, and also the legislation for COVID-19 recovery, I think we strongly believe that there will be more incentives and focus on the C&I market for energy storage in the next 2 years. From our analysis of the market, we have found that the revenue stream model for C&I ESS products is based on the revenue stacking. So by using the ESS in several different use cases, and where it would gain revenue over time. We think this is the main use case scenario for the ESS in terms of C&I utilization, and we are definitely happy that we can bring a product in this market that is highly optimized for this use case. In particular, for our product, we have been envisioning the following use cases. The first is demand management, that uses the battery power to cover the peaks in customer loads and avoiding to buy excessive amounts of energy from the grid. The arbitrage modes it's intended when buying power at low price and in times of low loads for charging the battery and selling the energy, or using the energy, of course, at time of high price and high loads for producing economic returns for the customer. Maximizing the self-consumption is actually one of the most recognizable uses of the ESS. It's storing all the excess energy from the solar or other renewable energy generators for later use when the solar energy available is lower, for example, in the afternoons or the evenings or even at night. The backup power is used when supplying power from the battery reserve during a grid outage situation, and to continue to power the user loads during the blackout. So this is also one of the uses where our product is highly optimized for. And finally, the fifth use case would be microgrid operation. And for example, it's when the product is used in conjunction with a diesel generator, a PV, or other renewable energy generators in combination with the local grid to manage the local demand as an independent grid system. So we will see a little bit more about that kind of operation later in the presentation. So when operating their businesses, our commercial and industrial clients, of course, face a whole set of challenges regarding the electricity supply and the power management for their company. In particular, electricity supply installation are very maintenance intensive, requiring expensive infrastructure to connect to the electrical grid and the complex work for ensuring the continuity of the business. Also, depending on where the business is located, the reliability of the power network could be an issue because there is maybe frequent power cuts or maybe voltage stability issues or that could interrupt the business at any time. The electricity cost is also getting higher and higher for the business users. And this is because the business growth is outpacing the electricity infrastructure quality that we have around us. And also because the regulating environments and the taxation is making electricity bills grow year over year for our business customers. Finally, most of the time, the business cannot control where it takes the energy. And the origin of the electricity supply is out of reach for our customers. So if the business would like to build an image of sustainability and green energy for their clients, then the only way actually is to make sure that the business is generating their own energy through renewable energy generators. So this is why more and more businesses are considering installing renewable energy sources as an option for electricity generation. And so when PV or wind are producing power, there is no better way. Actually, a C&I ESS system ensures that you are able to store the energy produced even when it's not consumed locally, and you are providing the stability that your business requires to operate in the best conditions, and you are maximizing your return on investment on your renewable energy generator. So it definitely makes sense for the businesses. We also think that the regulatory and incentives environment is going to be improved very greatly in the next couple of years. And so we are really looking forward for the market for C&I energy storage to grow more and more in the future. When creating our own C&I ESS solution, we at Sungrow have focused on what are the core attributes requested by the businesses as an ESS product solution. It has to be simple, both to install and operate. It has to be safe, using quality components and proven protection methods that will not endanger people and material on site. It has to be smart and enable behaviors and features that will provide multiple revenue streams for the customer. And it has to be effective, with the returns visible immediately for the customer and achieve a sensible return on investment in the current regulatory scenario. So we have definitely considered all that. Plus, of course, the advantage of having an all-in-one solution where in terms of service, in terms of maintenance, you only have to deal with Sungrow. Sungrow is going to be your only point of contact in terms of servicing and maintaining this unit in the future. So this is of course a huge plus on this kind of products. So this is our product, the ST159KWH-50 It is a highly integrated solution, and it has an environment-proof cabinet with inside a complete turnkey ESS solution, complete with a PCS, battery racks, safety and disconnection devices, and a single connection point for monitoring and control. It's a scalable solution capable of being utilized in several different applications and providing simple and reliable customer interface. We will see in detail now how we have designed our system to fulfill the requirement of safety and reliability and provide a smart and effective solution for the client, and also how it's going to become the scalability and the group management that we have done for this system will make it a very big asset in case of you want to make your system bigger in the future. So let's study a little bit more the simplified single line diagram, and it shows how the ESS system integrates with the rest of the equipment on site. So on the left, you see our customers' PV arrays that are connected to a PV inverter. And the production of this PV inverter is monitored by the first energy meter. The ESS is actually connected to the same AC grid as the rest of the loads on site. And the total site production and consumption is monitored by another energy meter that you can see on the right here. The ESS local controller is connected to both energy meter and to the internet, providing easy access to our portal Isola Cloud for the monitoring, and it also provides a direct connection to the client EMS interface, the energy management system of the client. So for example, right, here the ESS system may be working in the maximizing self-consumption mode. Okay, so the first energy meter would measure the energy produced by the PV inverter and report it to the local controller. Then the second meter, the second energy meter, would measure how much energy is being bought from the grid and injected, or maybe, injected into the grid. So based on this measurement, the local controller is able to compute how much power is being consumed by the load. If the PV generated power is higher than the load, then the local controller will use the surplus energy to charge the battery. But if the PV generated power is not enough to cover the load, then the local controller will discharge the battery to make sure there is no energy being brought from the grid. All of this is done in real time and with a very fast response time ensured by the local communication between the energy meter and the local controller, and the local communication between the local controller and the PCS to control how much power is being charged or discharged in the battery very quickly. Another use for this is, for example, a peak shaving mode, where you have, in this case, for example, the energy management system of the client actually connected to the local controller, and the energy management system will set targets where the load of the client must not be surpassed. And where the load of the client is surpassed, then it sends the instruction to the local controller to discharge the battery and cover the additional load that the client is producing. So this is a way for limiting the energy bill of the client. And also in this scenario, we have achieved the fast response time that make our product viable for peak shaving operation. So let's dive in now in the product and see the internal components. Its highly integrated nature means that it constitutes one complete unit. And its modularity means that every block operates with others as a unit. And therefore, it provides, first of all, redundancy and also resiliency and flexibility to the customer power generation. So the whole system that you see here in this slide has around 2 square meter footprint. So very compact. Inside we can see the following elements. First off, the PCS, it's the Sungrow SC50HV. It's a very reliable unit that we have been selling in other regions for quite some time with some success. It's a 50 kilowatt PCS with dedicated DC and AC breakers on the 2 sides of the product and a simple commissioning procedure. Then there is the double rack of Samsung E3 battery modules, which provides in total 159 kilowatt hour DC usable capacity. Samsung STI modules are NMC technology, and they are among one of the most reliable and safe in the industry. Also part of the battery rack is the system BMS and battery protection devices. On top of the battery rack, there is the Hvac unit that ensures ventilation and temperature control inside the unit and guarantees a regular operation even in tough weather conditions. We will see it a little later in the breakdown. The BCP is an acronym for Battery Connection Panel. And it contains the DC circuit protection, fuses, breakers, and UPS, and a 24-volt auxiliary power supply mode. The SC50HV PCS power converter outputs 400 volts by default. But if the customer needs a different voltage, the unit can also be fitted with a transformer that you see in number 6 here. It's working with cast resin or oil type transformers. They just need to be okay with the dimensions that fit in the enclosure. And yes, even the MV transformers are usable. For example, if you buy a bunch of these all-in-one ESS systems, you may want to connect them directly to the MV grid. And so in this case, this is also possible with the transformer. So this is a little bit of the breakdown of the different components inside the product. We think it's a great value, the compactness and the only one solution. And I think it's definitely standing out in the rest of all the other competitors in the market at the moment. Here we see that the outdoor cabinet is perfect for mounting outside. In fact, it is IP65 and C5 corrosion resistant. So in this case, the product can be installed in wet and humid environment, both in cold and hot weather, and it will still provide a flawless operation. We test extensively the IP protection and corrosion resistance rating of the product in our engineering labs, which are really impressive, actually. And we provide IP and corrosion test certificate and reports for our client when you buy one of our products. So it's a testament to the commitment of quality that Sungrow has in the development of these integrated ESS systems. And the local controller is the unique communication interface between the component of the ESS and the customer energy management system. It will get the information from the Samsung battery management system. It can also send commands to the power converter, and it's also connected to the energy meters to operate in various intelligent modes. On the customer side, it is connected to the EMS system of the customer through the open Modbus TCP protocol interface that we provide to all the partners and customers that want to interface with our system. The EMS, energy management system of the customer, can easily control the ESS for example, peak shaving mode or other smart operation mode that includes the control of the whole energy system. We understand that the main entry barrier for our customers and installers for installing a ESS system could be the complexity of installation and the perceived risk for the safety. So we addressed this in the design, and now we can see how our ESS product is designed with simplicity and safety in mind to make intuitive and reassuring to operate. First of all, the Samsung SDI battery cell on its own has already a thorough safety design. Every cell has a fuse protection device inside. It also integrates a relief valve in case of mechanical damages to the cell. A nail safety device is also present to protect the cell from puncture damages. And the overcharge safety device makes sure to avoid overvoltage events that could result in a thermal runaway of the battery cell. All these systems work together to provide the safety on all aspects: mechanical, chemical, electrical, and software control. There is, of course, Samsung SDI is well known for their long experience in the battery cell department, and they have a very good safety track record. And we are very proud of partnering with Samsung SDI for our joint venture. In addition to this, the ESS itself is designed for redundancy on the whole safety chain. We have, first of all, 3 levels of redundancy on the electrical protection, with the fuses on different levels, on the battery cell, the battery pack, and the battery rack. In addition to the protection devices for the DC circuit that you can find in the battery connection panel. We have 4 levels of battery management. So we have the BMS as in the battery pack, and then in the battery rack, and then finally the system BMS and the local controller that collects, they all collect measurements from each single battery cell. So like the voltage, the current, the temperature, the maximum allowable charge current. And they make sure that outliers are dealt with, are measured and reported to ensure the safety of the operation. We also have 5 levels of what we call the linkage protection, which means that in case there is a communication loss or a fault that is sent all along the chain, then the ESS can stop and put in safety mode. So we have the pack BMS, rack BMS, system BMS, and we have an emergency stop button too. So in this case, you can manually stop the product and put it in safety mode in case there is a problem or in case of intervention in the context of service or maintenance. Also the PCS can protect the system accordingly. Okay, let's dive in a little bit more in our Hvac design. The Hvac is the air conditioning and ventilation system that we include in this product, and it's designed to ensure optimal air convection in the battery. It is top mounted to make it easier to exchange air with the exterior. A canal system inside the enclosure actually ensures homogeneous distribution of the airflow to cool all the battery. The system is designed to control the interior temperature of the battery cells around 23 degrees with a variation of 0.5 degrees both sides, in order to be always in the best performance range of the battery for maximum power charge and discharge at all times. The Hvac can ensure nominal operation until 50 degrees C of the ambient temperature. So which means that until the environment does not reach the 50 degrees C, actually the product has no derating and can operate at nominal power. So this is an advantage that you cannot have if you don't buy a full all-in-one system solution, just like the one we are proposing now. The product can also be used in what we call the virtual synchronous generator mode. This operation mode allows the grid operator to use the ESS as an asset for grid stability. In fact, when the grid usually experiences a quick variation in load, this can generate an instantaneous drop in frequency. You can see it in the dashed line on the slide here. To avoid this, the ESS controlled in VSG mode will use the battery power to smooth the frequency variation using the virtual inertia control and the droop control algorithm. This results in a more stable local grid, which benefits, of course, the business operation of the customer as well. As mentioned before, in order to be profitable and bring a quick return on investment, the ESS must be able to enable several smart services at once for a stacked revenue stream. Therefore, the product must be designed to be smart and focused on the customer return. So now we will see how our design enable this functionality with our new product. So the local controller has a simple integration with the customer EMS system. In fact, it has a Modbus TCP protocol, and using that, the client EMS system can get all the data and all the measurements from the local controller, and also they can send commands like a charge and discharge from the battery to control the full system. In addition to this, the local controller is the brain of the ESS product, and it has several smart EMS modes already built in. So for example, self-consumption maximization mode used data from the existing PV inverter plant. The arbitrage mode allows tariffs to be entered in the local controller to establish the best times for charging and discharging of the battery. In microgrid operation mode, for example, the local controller will get the measurement from the battery and loads. And if the battery is low in the state of charge, then it will send, the local controller will send a command to the diesel generator, and it will start the diesel generator to provide the grid reference and even charge the battery if necessary. So it is to ensure the standalone operation of the microgrid system. Our ESS can also be used to guarantee the business continuity and the power generation continuity in an event of a power outage. So in case of a grid fault, the protection relay that is protecting the customer load will open. However, the ESS will stay on thanks to the UPS built into the battery connection panel. When the local controller gets the signal that the installation has been safely disconnected from the grid, then it will enter the off-grid mode in less than 2 seconds. After that, the battery power is available to provide the customer load power up to 3 hours at nominal power. The level of the battery SoC that you can reserve for this backup operation can be set in our local controller and Isolar Cloud portal. One of the main features of this ESS product is its modularity and scalability. Indeed, you can install up to 1 megawatt of power using this system solution. And the local controller from each device will synchronize together, and the whole plant can be visualized on our Isolar Cloud portal. This provides also redundancy, of course, and the flexibility to the whole system. So with small 50 kilowatt blocks, in case of issues or faults in one unit, of course, the rest of the units are still available for operation. And Of course, you can start by buying one and then expand the system in case the PV plant is also expanding. You will also be able to input the plant geographic information, performing some data processing and data analysis, as well as visualizing the financial performance of the plant. All of this using our iSolar Cloud portal. However, even more options are available if the customer decides to use a third-party energy management system where they can integrate, for example, with electric vehicle chargers and other business case scenario where it makes sense to have a commercial industrial energy storage system available. All in all, the customer and plant manager will be able to operate the units in coordination just as a virtual power plant, enabling revenue streams that were unfeasible in their flexibility up to now. So this has been a small introduction on our ESS solution. It's providing 50 kilowatt of power and 3 hours of storage, or 159 kilowatt hours of capacity. It is highly integrated with all-in-one design that is resistant to the environment. It is safe and reliable with built-in safety redundancy and a best-in-class thermal design. It is smart and efficient thanks to the integrated EMS and the off-grid operation management and the scalability of the system through group management. We truly believe that the development of commercial and industrial energy storage market in Europe will be growing very fast in the next 2 years, and we are ready to address the needs of our customer with our fantastic new solution. Sungrow has 5 years of experience in the energy storage business, more than 900 energy storage systems installed worldwide, and 0 safety issues so far. We have a joint venture with Samsung SDI in Hefei in China, where we have our production plant. We have a battery manufacturing plant and inverter production plant side by side. So we are bringing the best knowledge and experience on the table, and we are providing a system that we are sure is going to be considered one of the leading solutions in the market. Our ST159KWH-50 HV solution is available for pre-sales now. Of course, the question is whenever it's going to be able to be available for purchase and for delivery. At the moment, the system design has been finalized, and we are doing the certification for the Germany first and the other countries in Europe later. So we hope we can start selling in Germany later this year and in other countries in the beginning of next year. If you are interested in developing an ESS project with it, get in touch with me personally or with one of our Sungrow sales manager or local distributor in your country. Thank you for your attention. I think now is the time for questions. If you have any questions, and I will put my contact cards details on the screen available, and you can contact me at any time during the meeting. I think we can keep the presentation available and put my contact detail on screen like this, where we can provide. So yeah, thank you very much for the attention.
Thanks, Andrea, for that very informative and interesting presentation. Very much appreciated. We will now sort of conduct a Q&A. We've answered a couple of questions on the fly, but we have a few more as well. So I'll sort of talk through those in order. Obviously, with everybody listening and looking in on us, please feel free to sort of jump in with any other comments as they come up. We'll do our best. I think we're okay from a time point of view, so hopefully we'll sort of get everything through in order. So we'll just go back to the start. We've got a first question here. It came from Glenn. answered it initially, but he's asking how much does the HVAC consume, and from where is it fed?
Okay, the HVAC it's so we have an internal auxiliary power supply system that provides the HVAC with a power supply. It can be either connected to the grid directly, in case this is a grid connected system, or it can be connected to our transformer inside the ESS, in case it is an off-grid system. So it can work in case of grid outage, or in case the ESS is the only source of battery supply in the local grid. According to power consumption, we don't have official figures to provide yet for the HVAC consumption power, but when we are closer to release, we will definitely provide these numbers to the customers.
That's great, Andrea. Thank you for that. And Glenn also sort of asked as a precursor question, really, what the capacity of the battery is.
Yeah. So the battery, how we count the capacity of the battery is the usable capacity on the DC side. So you have a 159 kilowatt hour capacity on the DC side of the converter. So if you want to know the AC usable capacity side, of course, you need to factor in the losses of the power system on the AC side. So the converter losses, transformer losses, cable losses, and the rest of the system of the client that you may have. So again, we don't have the data yet of the efficiency curves for exactly for the converter, but for our experience with the SC50HV in the past, it has a very good conversion rate and a very good efficiency on the power conversion. So we are confident we will be class leading in case of efficiency of this system, compared to the competitors in this sector, I would say.
That's great.
The kind of details that we can provide a little bit more in the future, but for reference now, it's a usable capacity that we have declared using nominal power for charge and discharge in the battery on the DC side.
Good stuff. Jose asked the question, can the units be connected in parallel?
Yes, actually, this is one of the best features of the product. We have the possibility to connect many units in parallel and have them operate as one. So at the moment with the SC50HV, we were able to connect up to 1 megawatt of power, so 25 units in series when they are connected on the grid side. When they are connected in the off-grid situation, the unit number may vary depending on the strength of the off-grid installation, because one of the unit will act as a master and the rest of the unit will act as a slave. So it's going to be a variable number depending on your actually off-grid installation. So a deeper study must be conducted there.
Okay, good stuff. Glenn comes in with a follow-up question. Are there any regulations that we have to take into account when installing an ESS solution?
Yes, sure. We have the general regulations are the grid code compliance, of course, which it's required for any generation or storage products to connect to the grid with automatic disconnection devices. So in case of Germany, for example, we connect, we follow the VDE 4105 and 4110 standards. In case of the UK, you have the G99, G98, and G100 regulations. So these are the regulations that we should comply in case of grid connection points. There are other standards that we are expected to fulfill in case of all-in-one battery storage systems, and they vary for the European unit country by country. And depending on the country where we launch the system first and the country follow up in our priority list, we will definitely make sure that we are compliant with the required norms when launching the product in the market. So we have a local sales, technical support, direct contact with distributors and installers in the market. So if you are aware actually in your market of a specific behavior or grid code connection standards that you would like to share with us to make sure that we will be compatible when we will be launching the product in your region, please feel free to share it with me, and we will definitely look into having the system fully compliant when launching in your market.
Brilliant. Great stuff. Peter asked the question, can it also be run permanently via an off-grid system?
Yes, it has a black start feature, so it can start from no grid. So this is an interesting way to run the full system. However, at this stage, I will say it's better to integrate it in system where backup power generation supply, like the diesel generator, is available. But definitely it can black start in case there is no grid. Yeah, if the microgrid calculations are done correctly, I don't see any problem in having this as the only grid reference point for the microgrid.
Okay, good stuff. Anthony has a couple of questions. We'll go through both of them. The first is, he asks, what is the round efficiency of the system? And the second relates to a decrease in switch over time.
So the round trip efficiency of the system, we are not ready to share at the moment. However, we have very good charging and discharging efficiency with our SC50 inverter that is already on the market in other regions. And I would say we will be class leading or on par with the best competitors in the market in terms of round trip efficiency of the whole system. So we will be sharing these details with curves and full data whenever they are available. We will also make sure we integrate with the common microgrid sizing tools and energy storage and PV plant sizing tools to provide our efficiency data also to them, just as we have done with our other string and central inverters, in order to make sure that you can size your system correctly. So we will be providing the data closer to release, but expect industry-leading numbers from us.
Good stuff. Got a question here from Herbert. He's asking.
Yes, sorry, Jimmy. There is another question about decreasing the switch time.
Oh, that's correct. Yeah.
Yeah, with a third-party switch, for example, as not to drop loads. I think we'll have to investigate this a little bit more in details. If you have some companies that you know are producing this kind of external switches, definitely let me know. Get in touch with me, send me an email, and then we will see the detailed engineering requirements to get to. Of course, we would like to improve our switching time. At the moment, this is our design, but we are open for collaboration with other partners performing this. So if you have suggestions, please get in touch with me, and we will establish a cooperation for sure.
Good stuff. Got a further question here from Herbert regarding certifications. The required certifications being available in Germany by year end. I don't know if that's something you can shed any light on.
Well, we certainly expect so. Yeah. So if everything goes right in the certification and development phase, we will have the certification for Germany for full system energy storage available by the end of the year. Yeah.
Okay, good stuff. Next question's from Walter, and it's regarding the HVAC burden.
Yeah, basically it's the HVAC consumption probably. Yeah, same reply as before. Yeah.
Yeah, no problem. And he also follow-up question regarding inrush capability to support output.
So good question. I don't have exactly the numbers for our in-rush current and overload capability on the SC50. However, we know that there is in-rush capability and overload support for the system. I think it's not not as powerful as dedicated islanding ESS solutions, but it's definitely a competent system. So I will as soon as I get the special numbers, the exact numbers for this in-rush capability support, I will let everybody know, and we will probably follow up with a fact sheet or more detailed documentation when we near the market launch of the product.
Excellent. Good stuff. We've got a follow-up question. I think we've come to the end of them now from Arpan, and it's regarding e-certificate for the webinar feedback form. Yes, that's something I can sort of pick up with, and I'll speak to our webinar host, and I'm sure we'll be able to sort of circulate that in due course, so that won't be a problem. Mm-hmm. So unless anyone else has got any other questions, we'll give it a quick sort of 10-20 seconds or so for people to sort of respond. Happy to take any more questions as they come in. I believe we're coming to the end of that now, so all that remains is for me to thank Andrea again, and obviously all our audience for joining us today. Hope you found it of worth and you found it interesting. Also, I'd like to sort of point out that we will be hosting several further webinars this week. You can find at sungrowmarketing.com. And all that remains is for me to wish you all a good day, and hope to see you soon on our upcoming webinars. Take care, everyone. Bye now.
Thank you very much, guys.
Cheerio. Bye.
Ciao. Bye.